Hello, AP Environmental Science students. In today's screencast, we're going to go over the first section in Chapter 7, which covers climate and terrestrial biodiversity. The terrestrial biodiversity portion of this chapter was back in Unit 2. We're just going to look at climate for Unit 3. All of today's notes are from Living in the Environment, the 16th edition by Miller and Spoolman. So like I said, Chapter 7.1 focuses on what factors influence climate. So the main idea of this chapter is that an area's climate is determined mostly by solar radiation, the Earth's rotation, global patterns of air and water movement, gases in the atmosphere, and the Earth's surface features. So first we have to make a distinction between climate and weather. We all talk about the weather. The weather is a local area's short-term temperature, precipitation, humidity, wind speed, cloud cover, and other physical conditions of the lower atmosphere as measured over hours or days. So when we're talking about the fact that it's raining today, we're talking about the weather. Climate is an area's general pattern of atmospheric or weather conditions, measured over long periods of time, ranging from decades to thousands of years. So if we were to talk about the climate of Joliet, we would be saying we have warm summers and cold winters. So that's a pattern that we see all of the time. We have 4 seasons. And again, that's measured over decades to thousands of years. It's something we expect to see year after year after year. So there are 3 major factors that determine how air circulates in our lower atmosphere. And again, the lower atmosphere is where most of our weather patterns occur. So the first thing is uneven heating of the Earth's surface by the sun. We know air is heated more at the equator than at the poles. That's why the people located near the equator are living in warm tropical climates, while people living near the poles are in colder climates. Also, air circulates because of the rotation of the Earth on its axis. As the Earth rotates, its equator spins faster than its polar regions. As a result, heated air masses rising above the equator, moving north or south, are deflected west or east. So this helps to create wind cells and prevailing winds. And we'll talk a lot about the trade winds as a type of prevailing wind. These winds are able to distribute air, heat, and moisture. So if we take a look at an example here, the trade winds, they're going to go from the northeast to the northwest because as the Earth spins, it pushes the air in that direction. The third major factor is the property of air, water, and land. So heat from the sun evaporates ocean water and transfers heat from oceans to the atmosphere. This evaporation creates giant cyclical convection cells that circulate heat, air, and moisture. And some of those circulations are turned into currents. So the currents are mass movements of surface water. They're driven by those prevailing winds and the Earth's rotation, and they help to cycle the warm and the cool water from the ocean. To help this cycle, we have density. Cold water is more dense than warm water, so cold water is going to sink and flow beneath warmer and less dense seawater. This creates a loop of deep and shallow ocean currents that act like a conveyor belt. The shallow is the warm, the deep is the cold. We also have greenhouse gases that are in the lower atmosphere. Greenhouse gases allow visible light and some infrared and ultraviolet radiation to pass through our atmosphere. The Earth's surface then absorbs this energy and transforms it into heat, and then the greenhouse gases trap the heat in the lower atmosphere, which warms the Earth. Greenhouse gases include water vapor, carbon dioxide, methane, and nitrous oxide. Greenhouse gases are important because if we didn't have them, the Earth would be too cool for many of the things that live here to survive. However, when we hear greenhouse gases, that also usually has a negative connotation because human activities such as burning fossil fuels, clearing forests, and growing crops that release these greenhouse gases are increasing the amount of heat that we actually trap in, which is causing global warming. So here's a way to look at it. You've seen this figure before. Solar radiation comes in. The ozone, or those greenhouse gases, trap in the heat, so we can keep our Earth warm. Heat is also absorbed and released more slowly by water than it is by land. This helps to create our sea breezes, monitoring weather and climate of nearby coastal areas. So again, we've talked about this in class, but this is kind of why Chicago is known as the Windy City. The land is warm. It keeps the air above it warm as well. This causes a low pressure system over land because heat rises. Then over the water, we have a high pressure system that forms because colder air sinks. That colder air has to go somewhere, so as the warmer air over land rises, it moves into that space in the city, causing that wind to blow. There's also something known as the rain shadow effect, where mountains interrupt the flow of prevailing winds and the movement of storms. As air is forced up the mountain, it cools and it loses a lot of its moisture because that air condenses, and we create clouds and we create precipitation. So on the windward side, so where the wind is coming from, we get a lot of lush greenery, we get a lot of moisture. However, on the leeward side, which is where the air is flowing away from, because it's already let off most of its moisture on that windward side, once we get to the leeward side, we have a very dry environment because there's not a lot of moisture left in the air. So this figure shows that example. We see those prevailing winds that pick up moisture from the ocean. As it gets forced up, that moisture condenses into clouds. It's released either as snow or rain. And then once we get to this side, all of that moisture has been released already. We get to that leeward side. There's no more moisture to release, so we get these dry, warm, and arid land areas.